So we've just taken a look at two types of electrochemical cells, and notice that in any type of electrochemistry, there's always something that loses electrons and something that gains electrons. Chemistry defines the site of oxidation as the anode and the site of reduction, the cathode. And the way you're going to remember this is by the acronym UNOX, red cat. UNOX stands for anode oxidation. Red cat stands for reduction cathode. So the anode is always the site of oxidation. The cathode is always the site of reduction. And remember, oxidation means you're losing electrons. Reduction means you're gaining electrons. And this comes from the acronym LEO-GER. Lose electrons oxidation, gain electrons reduction. So remember, at the anode, you're at the site of oxidation, which means you're losing electrons and the oxidation number is increasing. At the cathode, you're reducing and you're gaining electrons, which means that you're becoming more negative. Apologies for that. That should be more negative. So, what occurs at one of the electrodes in both an electrolytic cell and a voltaic cell? In general, all electrochemistry, whether you're dealing with electrolytic cells or voltaic cells, the anode is always the site of oxidation, and the cathode is always the site of reduction. So the only one that correctly defines everything right is answer choice 2. Oxidation always occurs at the anode, NOx, and oxidation means you're losing electrons. So answer choice 2 is correct. In general, you're going to use that acronym. UNOX, red cat, means anode oxidation, reduction, cathode. And LEO-GER reminds you to lose electrons oxidation, gain electrons reduction. So, of course, the answer has to be choice 2. The diagram and balanced ionic equation below represents a voltaic cell with copper and silver electrodes and the reaction that occurs when the cell is operating. Describe the direction of electron flow in the external circuit in this operating cell. Please note that no matter what type of cell you're presented, nearly always you'll be presented with an equation that summarizes what's happening in the cell. Note what's going on. Here, copper is becoming copper 2 ion, and silver ion is becoming reduced to silver solid. So copper is losing electrons and silver is gaining electrons. So how would we describe the flow? Well, in every cell, electrons always flow from the anode, the site of oxidation, to the cathode. What would be the anode in this case? It would be copper, and the cathode would be silver, because the electrons are being lost at copper and flowing toward silver, where it's gaining electrons at the cathode. So we could just simply say that the electrons are flowing from the copper electrode. If you don't want to name the anode and the cathode, you could say the electrons are flowing from the copper electrode to the silver electrode through the wires and the voltmeter. Or you could say that the electron flow is flowing from copper to silver in the external circuit. Or you could just simply state from the anode to the cathode. And this is always true of the voltaic cell. A voltaic cell with magnesium and copper electrodes is shown in the diagram below. The copper electrode has a mass of 15 grams. When the switch is closed, the reaction in the cell begins. The balanced ionic equation for the reaction in the cell is shown below the cell diagram. After several hours, the copper electrode is removed, rinsed with water, and dried. At this time, the mass of the copper electrode is greater than 15 grams. State the direction of electron flow through the wire between the electrodes when the switch is closed. So, look at this equation and figure out which way the electrons are flowing. They'll either be flowing from magnesium to copper or copper to magnesium. Look at the equation and figure out what makes the most sense. If you want to be sure to get this question right, You can always say that the electrons flow from the anode to cathode, regardless of what the elements in question are. That always occurs in a voltaic cell. It always flows from anode to cathode. But if you wanted to reason from the equation why the electrons flow from magnesium to copper, well, look what's happening. Here we have neutral magnesium becoming magnesium ion. In order for that to happen, magnesium has to become oxidized, which means it's losing electrons. Where do those electrons go? They have to go to copper ion. And copper ion receives those electrons and becomes neutral copper. So copper ion gets reduced. So the flow of electrons is going to be from the magnesium to copper. Now you might be wondering, why does this happen naturally? Well, magnesium is higher on the activity series compared to copper. So magnesium is more reactive than copper and is much more easily oxidized compared to copper ion. Therefore, magnesium wants to lose its electrons to copper to become magnesium ion, thereby reducing copper. Which reaction occurs at the anode of electrochemical cell? In every anode of every electrochemical cell, it's always oxidation. Unox, red cat. Anode, oxidation. Cathode, reduction. So the correct answer is 1. So when it comes to defining what the anode and cathode are, remember that anox, red cat. Anode, oxidation. Reduction, cathode. Which part loses electrons? Well, you're going to use the acronym LEO-GER. Lose electrons, oxidation. Gain electrons, reduction. So the anode is the site of oxidation, meaning you lose electrons, and the reduction occurs at the cathode, meaning you're gaining electrons. Hopefully this was helpful.